So 2 minus x squared is equal to 1. Subtract the 2, negative x squared is equal to negative 1. Multiply through by negative 1, you get x squared is equal to 1, so x is equal to what? Yeah, positive and negative 1. So now, for step 2, draw a graph. And it doesn't have to be perfect. And since we're above the x-axis, I'm going to put a negative 1 there and a positive 1 there. I'll put a 1 there, and I'm going to draw this line at 1. And that's g of x is equal to 1, but it's also y equals 1. And that's our axis of revolution too, which is nice. Just happens to be both of them. Now I know that both graphs intersect here. Now to figure out what f of x is going to do, what I always do is I pick the middle point. What's the middle point? 0. So what's f of 0? 2 minus 0 squared, which is 2. So if I go up to 2, I know I'm going to get this because it's a parabola. So it's going to look kind of like this. Does that make sense how we came up with that graph? In this case, no. The x-axis doesn't come into play at all, outside of helping us graph points. Now, step 3, we have to draw a representative rectangle. And what we're looking for is this length, r, which goes from the top to the bottom. That's what we want to figure out. Now, what's the length from the x-axis actually comes into play now, because what's the distance to the top? All right, so the top of the rectangle is 2 minus x squared. And then what's the distance to the bottom? 1. So the bottom is 1. Anytime you're working with this and we're trying to figure out the length of the rectangles, you have to take from here all the way up. You have to start from the x-axis, because basically you're starting, think of it as a race. You're starting from a starting point. You always have to start from the starting line. Your x-axis or your y-axis is always going to be your starting line. So in order to figure out from here to the top of the rectangle is going to be 2 minus x squared. From here to the bottom of the rectangle is 1. So we have a rectangle now where I know that's 2 minus x squared, and that's 1. Because that's the distance here. So how do I calculate the distance of the rectangle, or that length of the rectangle? Yeah, subtract them. 2 minus x squared minus 1. So what's that going to end up being? 1 minus x squared. So every single time that you have to build your rectangle is you have to figure out, all right, well, in this case, what's the top going to be and what's the bottom going to be, and then I have to subtract it. In the original problem, with this rectangle here, if that was our rectangle, that was the square root of 4 minus x squared, and that was 0. Yeah, we were rotating about the x-axis, and that's fine. You're thinking about washers right now, but you don't know that you're thinking about washers, but you're thinking about washers right now. Right now, since we know we're rotating around this axis, we just really care about the size of the rectangle. That's all we're trying to find, is the size of the rectangle. And then since this is essentially the new x-axis, we're going to rotate around that. So this one would be square root of 4 minus x squared minus 0, top minus bottom, to get the length of your rectangle. Here, to get the length of the rectangle, is top minus bottom again. And we end up with this. Now, step 4 is you calculate your volume. Since we know we're rotating around x or y equals 1, and we're rotating around with this, you can essentially think that, all right, now the x-axis is gone. You can almost pretend this is the x-axis. I know what the dimensions of my rectangle are. So that's your big thing, is figuring out your dimensions of your rectangle. So my volume is going to be pi times the integral from, all right, that's negative 1 to 1, so I'm going to go from negative 1 to 1, of 1 minus x squared quantity squared dx. Because remember, the volume of the disk is equal to pi r squared times its width. Now, since this is a parabola, is this symmetric? So what can we say about this area right here and this area right there? They're equal, aren't they? So I can rewrite this and say 2 pi times the integral from 0 to 1. And remember, you can only do that when you're symmetric. Now, I want to expand this guy. So I'm going to use the formula of a perfect binomial squared. 1 squared is 1 minus 2x squared plus x to the 4th dx. And that's just, remember, from a minus b quantity squared is equal to a squared minus 2ab plus b squared. So it's nice to learn all that stuff, because then we can use it instantaneously. Alright, what's the integral of 1? X. What's the integral of negative 2x squared? Negative 2x cubed over 3. And then the last one's going to be x to the 5th over 5. And we're going to go from 0 to 1. Now, thankfully with 1, it's just going to be 1 minus, what, 2/3 plus 1/5. And then if I put in a 0, what do I get? 0. So that's the nice thing about having that. That all becomes a 0. So if I had that, it's minus 0. So I get 2 pi. Now I have 1 minus 2/3 is 1/3, isn't it? Plus 1/5. One-third plus 1/5. Common denominator is 15. That'd be 5/15, that'd be 3/15, so that's 8/15. What's 8/15 times 2/3? 2 pi. 16 pi over 15. So we didn't even need a picture. We didn't even need a graph or a calculator or anything like that. And it ended up being really nice for us. Now, I haven't seen these get too crazy. Every once in a while, the only time they do get crazy is when it becomes a calculator problem. And then you can always set things equal in your calculator, and then you can use your calculator. You don't want to just integrate it in the calculator. You write out the integral, and then you put the answer afterwards. So a lot of times with those, they look for the setup, and there's more points for the setup than it is for the actual answer. It's like out of maybe 5 points for that part, 4 are the setup and 1 is the answer. So if you know how to set it up properly, you're going to be in business.